Okay, so hello everyone. In this section, I was making a video, but for some reason, it froze and, But anyways, so in this next section, what we're gonna do, we're gonna already start to evaluate limits, okay? Now, so I did these first three, or these first two. So basically, here, let me just kind of write this down again. So if we have a limit, the limit as x approaches, for example, let's say the limit as x approaches 3 of 2x minus 3 over x minus 2. Then we can find the limit by doing direct substitution. Now, what is direct substitution? That means that all we have to do is literally just plug in x to find the limit. So to do that, we're going to do 2 times 3 minus 3 over 3 minus 2. So that's going to give us 6 minus 3 over 1, which is just 3 over 1, which is just 3, okay? For example, and also, let's pretend that, another one can be like the limit as x approaches 2 of 2x squared plus 4x minus 3. How do we find the limit? Well, you just plug in x equals 2, so 2 for x. And I say ds because that's direct substitution. Minus 3, and that's going to equal 2 times 4 plus 8 minus 3. That's 8 plus 8 minus 3. That's going to equal 16 minus 3, which is 13. Now, one of the things I really do like to do after I evaluate the limit, I like to write it in limit form. So I would say the limit as x approaches 3 of 2x minus 3 over x minus 2 equals 3, and you just box it. And then also here the limit as x approaches 2 of, let me actually, hold on. Okay. Of 2x squared plus 4x minus 3 equals 13. So that's pretty easy. I mean, all we have to do is just plug in the x value. However, sometimes it's not as simple. We have to do a little bit more. So let's go over one where we would have, so what I want to go over next is the zeros. Sorry about that, guys. I don't know why it started playing the video. Anyways, so let's see here. So this is a great example of what we just did. You just plug in 3 for x, and you get 10 over 19 is the limit, right? That's the limit as x approaches 3 of 2x squared minus 3x plus 1 over 5x plus 4 equals 10 over 19. I didn't do this one on my own, but that's exactly what we did over here. Right? Especially for this one. That's what we did for this part. Now, sometimes, it says, as we have seen, we may evaluate easily the limits of polynomials and limits of some, but not all. Keep this in mind, not all of them, but not all rational functions by direct substitution. And it says, however, as we saw in the introductory section on limits, it is certainly possible for the limit as x approaches a of f of x to exist when f of a is undefined. And yes, that's true. It is possible. Here, what they do is they say, okay, the limit as x approaches 1 of x squared minus 1 over x minus 1. What they do is they say, well, by direct substitution, and let me actually do this by myself, so the limit as x approaches 1 of x squared minus 1 over x, I think it was x minus 1, right? Yes, over x minus 1. If we do direct substitution, 1 squared minus 1 over 1 minus 1, that's 1 minus 1 over 0. This is 0 over 0. This is called the indeterminate form, which we cannot have, okay? A very common misconception is that people think, and this is something that I really, really don't want anybody to be fooled by, is the fact that because it is indeterminate, it does not exist. That is not true, okay? That is a very common error that people do in calculus. And even I'm pretty sure that they've even done it whenever they've been tested on exams. They've made that mistake. But the limit does exist. And the reason for that is because although we get 0 over 0, we can still find the limit. And how can we find the limit? Well, you can factor the top. This is x plus 1 times x minus 1. And then you divide it by x minus 1. Remember when I said to simplify? Like, I believe I went over this in, like, or even x plus 1. I'm sure I went over this in, like, when I used to do college algebra videos. That's because, yes, we have to know how to do this. This is x plus 1 times x minus 1 over x plus 1. This cancels out, so we're just left with x minus 1. Similarly, the limit as x approaches 1 of this, we cancel this one out, and we say this is equal to the limit as x approaches 1 of x plus 1. So then we go ahead and do direct substitution again, and we get 1 plus 1, which is 2. So thus, you're going to say the limit as x approaches 1 of what you already started with, x squared minus 1 over x minus 1 is equal to 2. Okay, and yes, this, I mean, like it said over here, if for all x does not equal a, so basically, especially this part, hold on, so it says, it says it is certainly possible, and I really, really want us to keep this in mind, for the limit as x approaches a of f of x to exist when f of a is undefined. Yes, and you have to remember that. Just because it is undefined at a point doesn't mean that the limit does not exist. Okay? If anybody has any questions about that, please let me know, because if that's something we really don't understand, if that's something that you're still having trouble understanding, I mean, it's going to be a lot harder like moving forward. Okay. So it says the limit has the form the limit as x approaches a of f of x over g of x, where the limit as x approaches a of f of x equals 0, and the limit as x approaches a of g of x equals 0. So then what we call this in math, when we say that, for example, it's like I said, the limit as x approaches 1 of x squared minus 1 over x minus 1. We would call this, so usually when we do this by direct substitution, it would be 1 minus 1 over 0, which is 0 over 0. We call this the indeterminate form. One of, to not get tricked by that, like to remember that just because you get this doesn't mean that the limit does not exist, because the limit does exist. And if you're having trouble, like, remembering that, a trick that my pre-calculus teacher taught me from high school is to say that when you evaluate it at x equals 1, and you get this is equal to 0 over 0, you can say, oh no, because we do not want 0 over 0 as the limit. So what are you going to do? You're going to factor. You're going to say that the limit as x approaches 1 of x squared minus 1 over x minus 1 is equal to the limit as x approaches 1 of the quantity x plus 1 times x minus 1. You're going to factor the top over x minus 1. This cancels out, so this is equal to the limit as x approaches 1 of x plus 1, which by direct substitution is going to equal 1 plus 1, which is equal to 2. So thus, like I said, the limit as x approaches 1 of x squared minus 1 over x minus 1 is equal to 2. Okay. Let me see. Give me 1 second. So let's do this one. The limit as x approaches 3, so of x squared minus 3x over 2x squared minus 5x minus 3. Now let's do direct substitution. 3 squared, because that's the first thing you want to do. You always want to make sure that it gives you indeterminate form. You always want to do direct substitution first. That's the first thing. So it's going to be 3 squared times minus 3 times 3 over 2 times 3 squared minus 5 times 3 minus 3, which is equal to 9 minus 9 over 2 times 9 minus 15 minus 3, which is equal to 0 over 18 minus 18, which is equal to 0 over 0, which means, oh no, right? Remember, this is bad. We don't want this. We never want this. We never want 0 over 0, ever. And 0 over 0 does not mean it does not exist, because it does. So you're going to go ahead. Actually, was it x squared or x cubed? Hold on. Okay, yeah, it was x squared. Okay. So then you're going to go ahead and factor the top and bottom. The limit as x approaches 3 of x squared minus 3x over 2x squared minus 5x minus 3 is equal to the limit as x approaches 3 of x, we're going to factor an x out of here, x times x minus 3 over, and we're going to factor the bottom. The bottom, I'm going to just go ahead and like do it this way. Hold on. So the bottom is going to be, we're going to factor it out. 2 times negative 3 is negative 6, and then we have negative 5. And we're going to do the box method as well because a is greater than 1. So we have, here goes 2x squared, and then we have, so we have two numbers that multiply to negative 6 and add to 5. All I can think of are negative 6 and 1. Okay. And so we do negative 6x, positive 1x, so x, and then my c value, which is negative 3. So then I say x, well actually it's going to be 2x times x, because if I do x and 2x, it's going to make this part not make any sense. And then 1 times x, and then I do 2x times negative 3, and 1 times negative 3. So what is this equal to? This is going to give me the limit as x approaches 3 of x times x minus 3 over 2x plus 1. So we're going to do, and I'm color coding so that you guys can understand what I'm doing here. 2x plus 1 over x minus 3. So notice here, these cancel out. And then we have x over 2x plus 1. Or actually, hold on, it's going to be the limit as x approaches 3. You have to keep writing the limit, because if you just write the function, you can get very confused and think that you're just simplifying the function, but you're not. You're finding the limit. Okay, so keep writing the limit as x approaches 3 of x over 2x plus 1. This is equal to 3 over 2 times 3 plus 1, which is equal to 3 over 6 plus 1, which is equal to 3 over 7. So therefore, you're going to say the limit as x approaches 3 of x squared minus 3x over 2x squared minus 5x minus 3 is equal to 3/7. Now, I want to make up a little problem. Hold on, give me 1 second. Okay, so let's do a few more. So we have the next one that I want to do, and I have my book here, which is, it's not pre-calculus for dummies, it's calculus for dummies, excuse me. All right, so these are just some other ones. So basically, let's try to do one a little more complicated. So the limit as x approaches negative 1 of x cubed plus 1 over, and let me make sure that it's, okay, over x plus 1. Now, for this one, obviously, if you do negative 1, you always want to do, like I said, you always want to do direct substitution just in case. Now, they're doing that, like, the more you do that, the quicker you can do it in your head once you, like, understand. You can start to understand whether or not it's what is it called? 0 over 0. But if you can't do it in your head yet, like if you can't evaluate this in your head yet, always just do it by paper. Negative 1 over negative 1 plus 1. So this is just negative 1 plus 1 over negative 1 plus 1 So this is equal to 0 over 0, which is, oh no, right? So we're going to do the limit as x approaches negative 1 of x cubed plus 1 over x minus, or x plus 1, excuse me. Now, for this one, you're going to have to remember what the sum of two cubes pattern is. This is equal to, and oh gosh, this is something that I won't lie to you guys, I always kind of forget. I believe it's a squared minus, is it, oh my, a squared minus ab I cannot remember. Give me 1 second. Okay, I got it. Oh my goodness. Alright, yes, this is what it is. I had to play with it around a little bit. So it's actually, I almost had it. It's not this. So a cubed plus b cubed is equal to a squared. So it's gonna be oh my goodness, hold on. It's gonna be a plus b times a squared minus ab plus b squared. Okay. Yes. So that means that x cubed plus 1, if we want to do, so for example, let's say, and I know this is like really unnecessary, but again, I want to make sure that you guys understand exactly what I'm doing here. So give me 1 second. So it's like this. So that means that x cubed plus 1, if I do x cubed plus 1 cubed, this is going to be really just x plus 1. So it's going to be x plus 1 times x squared minus x times 1 plus, and then it's going to be 1 squared. Okay, so this is going to be x plus 1 times x squared minus x plus 1. Okay, so in reality, this is equal to x plus 1 times x squared minus x plus 1. And then, let's see, over x plus 1. So we know that these two cancel out, and this is equal to the limit as x approaches 1, or negative 1, excuse me, of x squared minus x plus 1. And so by direct substitution, we get negative 1 squared minus negative 1 plus 1, which is equal to 1 minus 1 plus 1. Or actually, hold on, 1 plus 1 plus 1, which is equal to 3. So the limit, so we have the limit as x approaches negative 1 of x cubed plus 1 over x plus 1 equals 3. Okay. I had to play around with this a little bit. I always forget the formula, but luckily I got it. So, let's see, hold on. Okay, so now let's move on to square root limits. Let's try to do one that is, so let me see, hold on. I'm trying to see, so, for example, if we have the limit as x approaches 4, of 4 minus x over 2 minus square root x. Now let me first start with this. Simplify by getting rid of the square root on the denominator. Now there are some that you can take the, sometimes, like I said, it's always good to first do direct substitution. That's always your number one thing. For example, if I have the limit as x approaches 3 of, for example, x over 1 minus square root x, that would just be 3 over 1 minus square root 3. And I would say, if I want to get rid of the denominator, I would just say, okay, this is times 1 plus square root 3 over 1 plus square root 3. So it'd be 3 times 1 plus square root 3 over 1 squared minus the square root of 3 squared, because in reality this is some indifference pattern. So I would say 3 times 1 plus square root 3 over 1 minus 3. This is equal to 3 times 1 plus square root 3 over negative 2. So really, this would be 3 plus 3 square root 3 over negative 2. Okay. Now, some of them are not that simple, though. We're going to do one right now with square root limits. So we have... So let me actually... Hold on. Maybe in the book. So like right here, okay? This one, it says evaluating a limit by multiplying by a conjugate, right? So obviously when they plug in the limit, when they do direct substitution, it gives them 0 over 0. So what they have to do now is they have to multiply by the conjugate. And let me actually work this one out. The limit as x approaches negative 1 of the square root of x plus 2 minus 1 over x plus 1. By direct substitution, that's going to give me the square root of negative 1 plus 2 minus 1 over negative 1 plus 1. This is equal to the square root of 1 minus 1 over 0, which is, and it's the positive square root, okay? It's going to be 1 minus 1 over 0, which is 0 over 0, which is, oh no, right? Because again, we don't want indeterminate form. So what are you going to do? You're going to multiply by the conjugate. So you're going to say the limit as x approaches negative 1 of the square root of x plus 2 minus 1 over x plus 1 equals, so it's going to be, you're gonna grab this and you're going to say times the square root, and you're going to keep the square root the same, but the minus 1, you're going to do a plus 1, that's the conjugate, over. And then you're going to do the same thing on the bottom, multiply times the square root of x plus 2 plus 1. So now you're going to have the following, the square root of x plus 2 minus 1 times the square root of x plus 2 plus 1 over, and then the bottom you're going to say x plus 1 times the square root of x plus 2 plus 1. Okay, so here's the part where this is very important. Do not cross this out, okay? This part right here is there for a reason. Do not cross it out. Because I feel like a lot of people like do this and then they're like, oh, it gives me the same thing as I started with. And that's why, yeah, you don't want to do that. Don't cross that out. You're gonna, so on the top, you're gonna do FOIL method. So it's gonna be the square root of x plus 2 quantity squared plus the square root of x plus 2 minus the square root of x plus 2, and then minus the, or plus the -1 times 1 over, and you're going to keep the bottom unfactored, x plus 1 times the square root of x plus 2 plus 1, okay? So then this is going to be x plus 2, these two cancel out, and then it's going to be minus 1 because -1 times 1 is -1 over, and then you're going to keep it unfactored again, x plus 1 times the square root of x plus 2 plus 1. This is equal to, so it's going to be x plus 1 because x plus 2 minus 1 is x plus 1 over the quantity x plus 1 times the square root of x plus 2 plus 1. This is equal to, so we go ahead and cross this out. We have 1 divided by the square root of x plus 2 plus 1. And now you can do direct substitution again, so you have 1 over the square root of, and the limit, it was the limit as x approaches -1. -1 plus 2 plus 1, which is equal to 1 over the square root of 1 plus 1, which is equal to 1 over 1 plus 1, which is equal to 1 over 2. So the limit as x approaches -1 of the square root of x plus 2 minus 1 over x plus 1 equals 1/2. And this is your final answer. Okay. I would say that this one takes a little more work, but it's not that bad once you understand how it works. When like, basically my number one tip for these is do not FOIL out the bottom, because if you do that, it's going to make it really, really confusing. Only do the top, not the bottom. The bottom, keep it unfoiled. Do not multiply it out, because then it's going to make it harder, and then you're going to end up with something really weird, and you're not going to find the limit. Let's do another one. I'm going to try to do an easier one. So let me try to do a little bit of an easier one. So we have the limit as h approaches 0 of the square root of 4 plus h minus 2, and okay, and this is all over h. Again, you can do direct substitution. The square root of 4 plus 0 minus 2 over 0. This gives us the square root of 4 minus 2 over 0, which is equal to 2 minus 2 over 0, which is equal to 0 over 0. which is oh no, right? So then let's do what we did in the last problem, the limit as h approaches 0 of the square root of 4 plus h minus 2 over h. We're going to multiply by the conjugate, the square root of 4 plus h plus 2 over the square root of 4 plus h plus 2. This is equal to, so again, you're going to do, if you know by memory the sum of two, or the sum and difference pattern, that's great, because that saves you a lot of time. But for those of you who don't know it by memory, you can just say 4 plus h minus 2 times square root of 4 plus h plus 2, plus 2, and then you can do FOIL method on top, and keep the bottom unfactored, like I said, or keep the bottom unfoiled, like I said. Okay. So again, you're going to say that this, you're going to go like this, you're going to say this is the square root of 4 plus h times the square root of 4 plus h, and then plus 2 times the square root of 4 plus h, so times the square root of 4 plus h, and then minus 2 times the square root of 4 plus h, and then minus 2 times 2. Okay. And this would be, so you would do all over, and you're going to do h times square root of 4 plus h. So it's going to be plus 2, and then you're going to simplify the top. So it's going to be, so obviously this is equal to the square root of 4 plus h all squared. And then these two cancel out, and then you're going to have minus 4 all over h times the square root of 4 plus h plus 2. And then you have 4 plus h, because the square root cancels out, minus 4 over h times the square root of 4 plus h plus 2. And then you have, this is equal to h over h times the square root of 4 plus h plus 2. This cancels out, and you are left with 1 over the square root of 4 plus h plus 2. And you want to find the limit as h approaches 0. Remember, the limit as h approaches 0 of 1 over the square root of 4. It's going to be 1 over square root of 4 plus h plus 2. By direct substitution, this is going to give you 1 over the square root of 4 plus 0 plus 2, which is equal to 1 over the square root of 4 plus 2, which is equal to 1 over 2 plus 2, which is equal to 1/4. So therefore, the limit as h approaches 0 of the square root of 4 plus h, 4 plus h minus 2 all over h is equal to 1/4. Okay. Give me 1 second, guys. Hold on. And And yes, I'm going over this very slowly because, I mean, again, I don't want to confuse anybody or get anybody lost. I'm not sure if I did this part or this one. But anyways, okay. So this is an interesting one. The limit as x approaches 1. So let me see, hold on. The limit of the quantity 1 over x plus 1 minus 1 over 2 all over x minus 1. Of course, by direct substitution, you're going to get 1 over 1 plus 1 minus 1/2 all over 0. This is going to give you 1/2 minus 1/2 over 0. This is just 0 over 0, which is, oh no, right? Now this one is interesting, okay? What you're going to do for this one, you're going to go ahead and simplify this part, the top. So if we do that, we have, obviously we can use this form. So we can do cross multiplication. So we have 1 times 2 minus 1 times x plus 1 over 2 times x plus 1. That's equal to 2 minus x minus 1 over 2 times x plus 1. This is equal to negative x plus 1 over 2 times x plus 1. Yes. And then let's see here. Hold on. So it's negative x plus 1 over 2 times x plus 1. So then we would say negative, so it'd be negative x plus 1 over 2 times x plus 1, and it's the limit as x approaches 1, right? And then this would be all divided by 2 times x plus 1, so, or, no, x minus 1, excuse me. So this in reality would be the limit as x approaches 1 of the following: negative x plus 1 over 2 times x plus 1. Now you have to be careful because these do not cancel out, okay? Be very careful. Because yeah, those don't cancel out. They're not going to cancel out. So this is really just one term on its own, negative x plus 1. And then you're going to do divided by x minus 1. So it's going to be the limit as x approaches 1 of negative x plus 1 over 2 times x plus 1 times 1 over x minus 1. So then this will give you, okay, hold on. So it'd be the limit, and I hope I'm doing this right actually, hold on. So this can then be the limit, so it can be the limit, and you can factor out the negative. So you can say of negative the quantity x minus 1 over 2 times x plus 1 times x minus 1. So now you can cancel it out. And this gives you negative 1 over, so this gives you the limit as x approaches 1 of negative 1 over 2 times x plus 1. And what is that? That's going to be negative 1 over 2 times 1 plus 1, which is equal to negative 1 over 2 times 2, which is equal to negative 1 over 4. So therefore, the limit as x approaches 1 of negative x plus 1 over or actually, as x approaches 1 of 1 over x minus 1 minus 1/2 over x minus 1, right? Or sorry, x plus 1 minus, 1 over x plus 1 minus 1/2 over x minus 1 is going to be negative 1/4. Okay. So yeah, that's basically how you do it, and you see negative 1/4 right here. Let's do this one. So the limit as x approaches negative 3, so hold on. The limit as x approaches negative 3 of 1 over x plus 2 plus 1, so all over x plus 3, I think. Yes. And obviously, if we do direct substitution, it's going to be 1 over negative 3 plus 2 plus 1 over negative 3 plus 3. That's going to give us 1 over negative 1 plus 1 over 0, which is negative 1 plus 1 over 0, which is equal to 0 over 0, which means, oh no, indeterminate form. We don't want that. So we're going to go ahead and say that the limit as x approaches negative 3, and we're going to, again, do the same thing that we did in the last one. We're going to go ahead and simplify this part. So obviously, we're going to do 1 over x plus 2 plus 1 over 1. This is equal to 1 times 1 plus 1 times x plus 2 over x plus 2 times 1. This is equal to 1 plus x plus 2 over x plus 2. This is going to be equal to x plus 3 over x plus 2. And then, so that's what that equals. That's this part here, okay? So we can put that for the top part, so we can say that the limit as x approaches negative 3 of 1 over x plus 2 plus 1 over x plus 3 equals the limit as x approaches -3 of x plus 3 over x minus 2, or x plus 2, excuse me, divided by x plus 3. And then we have the limit as x approaches -3 of x plus 3 over x plus 2 divided by x plus 3. This is equal to the limit as x approaches -3 of x plus 3 over x plus 2 times 1 over x plus 3, which is, and they cancel out, so it's equal to the limit as x approaches -3 of 1 over x plus 2, which by direct substitution is equal to 1 over -3 plus 2, which is just equal to 1 over -1, which is just equal to -1. So the limit as x approaches -3 of 1 over x plus 2 plus 1 over x plus 3 is equal to -1. Okay. Let's see, hold on. I mean, I don't even think they gave us the what is it called? The answer for that one, but it's fine. Okay, so this one says the limit as x approaches 0. So, okay, hold on. Of the following: 1 over x plus 5 over x times x minus 5. Again, by direct substitution, if we do that, we're going to get the limit. So by direct substitution, that's going to be 1 over 0 plus 5 over 0 times 0 minus 5. That's just going to be 1 over 0 plus 5 over 0, which cannot happen. I mean, it's going to be 6 over 0, but that's going to be like... No, that's going to be like undefined plus undefined, which cannot happen. That's indeterminate. So the way that we do this is we're going to go ahead and add this up. So we have 1 over x plus 5 over x times x minus 5. We have 1 times x times the quantity x times x minus 5 plus 5 times x over, all over, x times x minus 5. This is going to give us x, and it's going to be x times x minus 5 plus 5x over x squared times x minus 5. This is equal to x squared minus 5x plus 5x over x squared times x minus 5. This is equal to x squared over the quantity x squared times x minus 5, which is equal to 1 over x minus 5. Okay. And it's the limit as x approaches 0. So the limit as x approaches 0, by direct substitution of that, would be of 1 over x minus 5. By direct substitution would be 1 over 0 minus 5, which is just -1/5. So therefore, the limit as x approaches 0 of the following: 1 over x plus 1 over, or 5 over x times x minus 5 is equal to negative 1/5. Okay. Let's see, what else? Now, this one, so it's like I said in the last video, you want to do a table for this, okay? Because, like I said, it's going to be 2 as x approaches 2 from the left side, that means it's going to go 1.9, 1.999, 1.99999, etc. And so in reality, I mean, yeah, that's just how it works. Now, there is something called the Squeeze Theorem, which, I mean, I will not lie, it's a little bit too complicated for me to explain. I am sorry, guys. I mean, I did do this in Cal 1, but it was very difficult. I only say that because basically it's just really, it's very difficult for me to explain. I'm not 100% sure how to do Squeeze Theorem. Now, there are two things, and I guess that's for the next video. Like, once we get into what is it called? So basically, okay, so the last thing that I do want to get into in this video, and this is the last thing, is trigonometric limits. Now, trigonometric limits, oops, my bad. Trigonometric limits are, so they're very essential, and they prove the following theorems. The limit of as theta approaches 0 of 1 minus cosine theta over theta, and they say that this is a theorem. The limit as theta approaches 0 of 1 minus cosine theta over theta equals 0. Now, I'm not sure why this does not really have, and also there's a limit as x approaches 0 of sine of x over x, that's going to be equal to 1. Now, I'm not sure why they do not, I'm assuming, I don't know if in 2.5 they do it. Okay, so I don't know if this book actually goes through the what is it called? Through trigonometric limits. I might just save that for the next video, because I don't want to make this video way too long than it already is. But I will do trigonometric limits in the next video. So if anybody has any questions, please let me know. I do have some examples of trig limits. I just don't want to do it in this video because I mean, I don't know why. I thought it was going to do trigonometric limits in a later section, but I don't know. It's just not... It just doesn't make a lot of sense to me why it's not doing it. But anyways, we're going to do trigonometric limits in the next video. Okay, so with that being said, guys, thank you so much for watching. I know these videos are kind of long, but I really am trying my best to help as much as I can, because I really don't want to, I mean, obviously, yes, there are going to be questions, but I always want to make sure my explanations are as clear as possible, or as clear as I can make them, because I know some of this stuff is kind of confusing, so, but regardless, like I always say in every video, if anybody has any questions, please let me know, and in the next video, we're going to be doing trigonometric limits. So with that being said, guys, thank you so much for watching. Please like, comment, and or subscribe to my YouTube channel, and I will see you guys in the next video. Thank you so much, guys. Bye-bye.